All right, so welcome to this video. In today's lesson, we are going to be revising our questions from quiz 1, and the course is Introduction to Statistics. Okay, so we just have two questions in this particular quiz, okay, and we're going to go over all the questions that we can see here. So we start from question 1. Okay, so question 1 says define the following. Okay, define the following. The first part, they're saying define a parameter. Okay, so parameter, it's a very simple definition. You're going to say a parameter. Okay, a parameter is a numerical property. Okay, numerical property of a population. Okay, this is what we call as a parameter. So in short, this parameter, okay, should describe, okay, this parameter should describe the whole population that you're dealing with. Okay, so I'm going to give an example. So for example, if let's say you want to find the average age of all the students that are at UNZA, okay, it means there you're talking about the average of the whole population because you are talking about all the students that are at UNZA. Okay, so we're going to say, for example, the average age is mu is equals to, we can say 23 point maybe 4 years. Okay, let's say this is the average age of all the students. So you can see that this mean is describing something about the whole population of what students. So we call that as a parameter. Okay, some other important parameters that we have to know, okay, include the population variance, which is just indicated or represented by sigma squared. We have population standard deviation indicated by sigma. Okay, some of you say, some of you think this is a 6. No, it's not a 6, it's a sigma. Okay, and then we have population proportion, which is indicated by a small letter p, like that. Okay, so these are some of the parameters, okay, meaning a numerical property that describes something about the what? The population. Okay, the second definition that we've been given here is to define what a sampling distribution is. Okay, so now that word is self-explanatory because they're saying sampling distribution. Okay, so in defining it, it should be the distribution of something, right? Okay, so how do you define sampling distribution? So in simple terms, you're simply going to say a sampling distribution. Okay, a sampling distribution is the distribution, okay, is the distribution of a statistic. Statistic. Okay, not the statistics, no, but a statistic. So now what is a statistic? Okay, statistics is just the counterpart of the parameter. So this here, when you hear statistic, okay, it's a numerical property. Okay, numerical property, okay, of a sample. So this one will be describing something about the sample. For example, the sample mean to be represented by X bar. The sample variance, that would be S squared. Sample standard deviation, it will be S. Okay, so these are some of the common statistic that we have. Okay, so now this sampling distribution, it will just be the distribution of a certain statistic that you're talking about. Okay, so later on you get to know, like, if we are talking about the distribution of a sample mean, okay, we'll get to understand these things more. All right, so yeah, those are the definitions, and then now I can move on to part B. Okay, so this is part B. So part B is a very good question because we're going to see how we can actually construct a grouped relative frequency distribution table, okay, from this question, how we can describe the shape of the distribution, okay, how we can construct a box plot for this data, how we can find the percentile rank, the percentile, as well as how we can actually find a confidence interval, okay, um, for standard deviation. Okay, so it's a very good question. Okay, it's going to teach us a lot of things. Okay, so the first thing that you have to do whenever you're given such a question is just actually order your data, okay, from the lowest to the highest. So here the question says, the following observations, okay, represent ages of 25 students selected, okay, at random from a certain college. So I said the first thing is that you have to order this data, okay, from the lowest to the highest. So which number is the lowest there? Okay, so when you look at these numbers, I can see a 10 there. So that would be my lowest. So 10 is my lowest. Okay, 10. And then from 10, I can see 12. And I can see multiple 12s. So I have 1, 2, 3. 3 of them. So I'm going to write 12. Okay, 12 and 12. Okay, from 12, the next number that I can see is 14. Do I also have multiple 14s? I think so. So 14s, I have 1, 2, okay, 3, 4. So I'm going to write the 4 14s here. Okay, and then from there, we go to the 16. How many 16s do we have? 1, 2, 3, 4, 5. So we have 5 of them. So that is 16. Okay, 16, 16, and 16. We have 5 of them. So I'll write the other 16 here. Okay, then from 16, I didn't cancel this 10, so I should cancel it. From 16, I go to 18. How many 18s do I have? I can see 1, 2, 3, 4, 5. So that is 18. Okay, 18, 18, 18, 18. So I have 5 of them. 1, 2, 3, 4, 5. Okay, from 18, which number comes after the 18? Okay, do I have any 19 there? Okay, let me check. 19, 19. I can't see any 19, so I'm going to move to 20. Okay, so 20, that is 20. I have 1, 2, 3, 4. So I have 4, 20. So 20, 20, 20, 20, comma. From 20, I go to 22. Okay, 22, I have 1, 2. Okay, I have 2 of them. And then I have 24. Okay, so 24 is there. I cancel it as well. So you can see I've canceled every number here and I've ordered this in order. I've put this in order. So this is, let me count if they're 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Hey, it means some of these we have written them twice. Okay, let me just count the check. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oh, okay. There are 25. Okay, so I've ordered my data and then now I can start answering the questions. Okay, I can start answering the question. So the first one, number 1, says construct a grouped relative frequency distribution table, okay, for the data using the classes 10 to 12, 13 to 15, okay? So you can see that the width of each class will just actually be 3, okay? Because the width, you get it vertically. Okay, so I want to draw a grouped relative frequency. So it's just going to have like 3 columns. Okay, we have the ones with the intervals, and then the frequency, and then the relative frequency. Okay, so it's going to be very easy. So I'm going to say, okay, let me draw this table. Okay, and then I'll have my first column there, second column, um, the frequency. If you want, you can put the third there, but it's not necessary. And then I have the relative frequency there. Okay, relative frequency, like that. So here, I'm going to put the classes, okay, or we can simply call them as the interval. Okay, you can call it as the interval, or you can say age group or something like that. Okay, or age classes, intervals, classes. It's okay. So age classes. Okay, so I'm just going to start from where they are starting from here. Okay, so they said 10 to 12, and then 13 to 15. No wonder I said the width is 3, because the width you always subtract 2 consecutive lower bounds or 2 consecutive upper bounds. So from here, I just have to add the 3 to this guy. I get 16. 3 to this guy, 18. Okay, 3 to this guy, 19. 3 to this guy, I get 21. Okay, 3 to this guy, we get 22. And 3 to this guy, we get 24. So there will be no need here to write another class, okay? Because this class will have the highest number there, which is 24, this guy. Okay, so I'll just end there. Okay, and then here, of course, we're going to have the frequency. And then here, we're going to have the relative frequency. Okay, very easy things. So now we just have to count how many numbers are between 10 and 12. So that would be 1, 2, 3, 4. So that would be 4. So I'm going to write 4. Okay, how many numbers are between 13 and 15? 1, 2, 3, 4. So that would be 4. And how many numbers are between 16 and 18? That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have 10 there. How many numbers are between 19 and 21? I have 1, 2, 3, 4. So that would be 4. Okay. And then how many are between 22 and 24? 1, 2, 3. So that would be 3. Okay, so let me just write a line down there. So you can even put a line there. Okay, and then you write this as the total. So what would be the total frequency? Summation of the F will just be equals to, we just add, and it should give you the number of students that you had, which is 25. So 4 plus 4, okay, that is 8 plus 10, 18, plus 4, 22, plus 3, 25. So we are correct. So 25. And then the relative frequency, we know how to find the relative frequency, right? So relative frequency is equals to the frequency of that class divided by the total frequency. So here it will just be 4 multiplied by, 4 divided by 25. So 4 divided by 25. What do we get? That will be my relative frequency there. Okay, and this is 0.16. Again, to be 4 over 25 and 0.16. Then to be 10 over 25 for this guy. So the relative frequency there will be to just be 0.4 according to my calculator. And then the 4, we already know the answer, 0.16. Then the 3 over 25 gives what now? Gives 0.12. So when you add, okay, the relative frequencies, the total should give you a 1. Okay, and when you try that, you're going to see that you're going to get a 1. Okay, so let me try. So 0.16 plus 0.16 plus 0.4 plus 0.16 plus 0.12 add, I'm going to get a 1. So always, okay, the total relative frequency there should be a 1. Okay, so what we have done here is answered part I, or part 1. We've drawn, okay, or constructed a grouped relative frequency distribution table using the classes 10 to 12, 13 to 15, and so on. So it means you are done with the first part. Okay, what about the second part? The second part says describe the shape of the distribution of the data. Okay, so if you are used to such questions, you can be able to tell the shape and the distribution of the data by just looking at the frequency. But if not, you can just try to come up with the some sort of a diagram, okay? And then from that diagram, you will be able to tell the shape of the distribution. So for you to do that, you're just going to plot the frequency, okay, against, you're going to plot the frequency against the classes. So I'm just going to quickly come up with a diagram here, like that, okay? So you plot some sort of a histogram, but here you're just using it to describe. So there's no need to make it like accurate and the like. So if this is my 0, you look at the frequencies, okay? There's 3, 4, 4, and 10. So let me say I have 2, 4, 6, okay, 8, and then 10. And then here on the 8 classes, okay, the lowest was 10, and then it went to 14. So I'm just going to come up with a rough one, not an accurate one. Okay, unless the question asks you to draw the histogram, then you have to make it continuous by finding the boundaries and the like. But here I'm just going to say, okay, 12 to, 10 to 12. Okay, and then from there, we'll go to uh, 15. I'll go to 18. I'll go to what is that guy now? 18, 21, and then 24. Just to help me have an idea of what this shape looks like. So from 10 to 12, I go up to 4. Okay. From 13 to 15, I'll just say 13 is somewhere there. Okay. So it's like I'm drawing the bar graph here, not even really the histogram. Okay, because the histogram is continuous and there should be no gap. Okay, so let me just say this. Okay, so just using it for the sake of knowing the shape, I'm going to say, okay, it ends there. Then the other one starts from here. Again, it has a height of 4. The other one starts at 16, goes to 18, it has a height of 10. So this one goes to 10 like this. Then it comes down. The other one starts at 19, it has a height of 4. Okay, and then the other one starts at 22 to 24. Okay, so it has a height of 3. So if this is 2, this is 4, 3 should be somewhere in between. So it's somewhere there. Okay, so now when you look at the shape, okay, that this distribution is forming. Okay, so this just should be some rough work somewhere. You can see that it is actually it is approximately symmetric, right? Okay, it's approximately symmetric. If you try to just draw a curve, okay, through this diagram that we've done. Okay, if I just say I draw something like this, you can see that it is approximate symmetric. Okay, so how are you going to describe it now in part 2 there? Okay, you are simply going to say from the frequency distribution, okay, this distribution that I have here, the frequencies rise, okay, towards the middle and then decrease again, because you can see it rose here and then it decreased like that. Okay, it increased and then it has decreased on the other side. Okay, so we're going to say according to the frequency distribution, okay, The frequencies rise toward the middle and then they decrease again. So therefore, okay, the shape, okay, is approximately, okay, the shape is approximately bell-shaped and symmetric. Okay, so that's how you can describe the shape of the distribution of that data. All right, so we are done with this. The next thing now is to find or construct a box plot. Okay, so a box plot is a 5-number summary, and sometimes we can actually show the mean, okay, there. But most of the times we don't show the mean there. We just show the 5-number summary. So the 5-number summary, it means the minimum, okay, the maximum, Q1, Q2, Q3, and sometimes we're required to show the mean. Okay, so now the maximum and the minimum just get from the ordered data. So the minimum is 10, the maximum is 24. But now how do you find these quartiles here? Okay, so the quartiles, you simply use you first define the approximate position where you can find this quartile, and then go to the ordered data and get the quartile. Okay, so position of, okay, the kth quartile is equals to, okay, position of the kth quartile is equals to, um, okay, what should I say here? Is equals to k, okay, multiplied by, um, um, how should I write it in general? I want to write the formula in general, and then we can pick it up from there. Okay, so it will be k divided by 4. Okay, should be k divided by 4. No, should not be k divided by 4, but it should be, what's the general formula? That's gone. Okay, so but for the Q2, supposed to give me a 1 over 4. Okay, um, not 1 over 4, but 2 over 4. For the Q1, supposed to give me a 1 over 4. Then for the Q3, supposed to give me 3 over 4, like that. Okay, that is what it's supposed to give me. So now how do I write this formula in general? Okay, so in general, the kth quartile is given as k, okay, divided by 4. Okay, so the position of the kth quartile is given by k multiplied by n and then divided by 4. So k is the quartile that you're dealing with. So if you're dealing with the second quartile, you have to put the 2 there. Okay, if it is the first quartile, you put 1. If it is the third, you put 3 there. Okay, and then this n here will just be the the size of the sample. So in this case, my n will be 25 since I'm dealing with 25 students. Okay, so let's find the position of these guys and then actually extract them. So I'm going to say, okay, the position of Q1 is just going to be equals to, my k is 1, so that would be 1 multiplied by this n and then divided by 4. So 1 multiplied by 25, then divided by 4, that will just be equals to, okay, that will just be equals to about 6.25. So now, when you find a position which is not an integer, okay, when you find a position which is a non-integer, you have to move to the next higher integer. So you round up, okay? So this position will just be approximated to, if I round this up, I'm going to get to the 7th position, okay? So in this my ordered data, I'm going to find my Q1 at the 7th position. So that would be 1, 2, 3, 4, 5, 6, 7. So my Q1 will be 14. Okay. What about the position of Q2? It will be 2 multiplied by 25 over 4. So this will just be 12.5. Okay, as you can see, this is non-integer number, okay, because there's a point. So meaning that I'm going to round it up, okay, or I'm just going to move to the next non-integer number. So from 12, I go to 13. So my Q2 is at the 13th position. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13, that is 16 there. Okay, let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I pick this 13th observation, which is 16, and I can now find the position of a Q3, which will just be 3, okay, multiplied by 25 divided by 4. So this will be equals to, if I multiply that, okay, the numerator will give me 75 divided by 4. That will give me 18.75. So I move to the next integer. So this will just give me 19th. So the 19th observation is my Q3. So if this is 13, then this is 14, 15, 16, 17, 18, 19. So I'm just going to get 20. Okay, I'm going to get 20 as my Q3. Okay, and then what is the mean? So the mean means we just have to add everything and then divide by 25. So it's the summation of all the xi's that I can see there divided by 25. Okay, so I can pass that on my calculator. 10 plus 12 plus 12 plus 12. Okay, how many 12s there? 3 plus 4 14s. Okay, plus 5 16s plus 5 18s plus 4 20s. Okay, plus 4 20s plus 22 plus 22 plus 24. Okay, and then I'm going to divide that by 25. Okay, so I find 420. Please confirm with your calculator. Then I divide by 25. I'm going to find 16.8. Okay, find 16.8. So I'm going to say this here is 16.8. That is my mean. Okay, so I have everything now that I need in order to find or construct this box plot. Okay, so let's construct our box plot somewhere here. Here. Okay, so our box plot, when I look at these numbers, the lowest is 10. I think the highest is 20, and everything is just in between. So I can move in terms of increments of 5. So I can say, okay, I have a 10 at the beginning. Okay, then I go to 15, then I go to 20. Okay, I go to 25. Okay, something like that. In fact, here we've not found or tested if this guy has some outliers. Okay, anyway, we'll do it at the end. So now, what you need to do is that you draw a vertical line at the maximum, minimum, and all the Q1, Q2, Q3. So what I'm going to do here is that the minimum is 10. So I'll draw a line there. Okay, vertical line. The maximum is 24, so somewhere close to the 25. Okay, the Q1 is 14. So closer to the 15, right? So somewhere there. And the Q2 is 16. So after the 15, so somewhere there. Q3 is 20. Okay. And then the mean is 16.8. So if this is 15, this is 16, 16.8 should be somewhere there. So you represent the mean, okay, with a plus sign. So somewhere here, I'm going to have the mean like that. Okay. All right, so now we just have to connect the three lines in the middle like that, and then you draw whiskers that connect to the maximum and to the minimum. Okay, so this guy here is going to be my minimum. This will be Q1. This will be Q2. This here will be Q3. This here will be my maximum. And then this guy there with indicated with a plus, that will be my X bar. That will be my mean. Okay, but we do not check if this guy has some outliers. So to check if it has outliers, first I have to find the range of accepted values, the RAV. Okay, the RAV. So range of accepted values will be, okay, range of accepted values will be Q1 minus 1.5 interquartile range, comma, Q3 plus 1.5 interquartile range. Okay, so let's find those things separately. So Q1 is 14 minus 1.5. Interquartile range is Q3, which is 20 minus 14 Q1. Okay, comma. Q3, which is 20 plus 1.5, 20 minus 14. So what do these guys give us? Okay, so for the first part, I have 14 minus 1.5. Then in the brackets, I have 20 minus 14. Okay, so that gives me a 5, comma. The other side, I have 20 plus 1.5 in brackets, 20 minus 14. That will be 29. Okay, so this range of accepted values says from 5 to 29. Okay, so now among this data that I have, okay, is there any entry that is below 5 or greater than 29? The answer is no. So we have no outliers here. So we don't need to show any outliers on the box plot there. Okay, we don't need to show any outliers on the box plot. Okay, so it means we are done with part 3. We can now look at part 4. Okay, so let me do this, duplicate so that that box still remains somewhere. Then I can erase this now. Okay, so how do you find the percentile rank? Okay, so I just have to follow the formula. So the percentile rank of X is equals to the numbers, okay, below the X. So you count how many numbers are less than X, plus half divided by, uh, plus half multiplied by number, or the number, okay, equal to X. And then I divide all this by N, which is the sample size, okay? And then I have to multiply this by 100. So now I don't have space here, but I multiply by 100. Okay, so now we want to find the percentile rank of 18, okay? So 18 is there. So first I have to count how many numbers are below this 18, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number below this 18 guy, okay, because we're finding the percentile of 18, the numbers that are less than 18, okay, are 13. Then plus 1 over 5 multiplied by, here, 1 over 2 multiplied by the numbers that are equal to 18. Okay, so numbers that are equal to 18, 1, 2, 3, 4, 5. So that is 5. Then divided by the sample size 25, then multiplied by 100. Okay, so let's deal with this now on the calculator. So I have, okay, I have 13 plus half of 5 is 2.5, right? So 13 plus 2.5, and then multiplied by 100, and then divided by 25. Okay, so that's going to give me 62. Okay, so what does that mean? It means the percentile rank of 18 is approximately 62. Okay, that is an age of 18 is approximately, okay, at the 62nd percentile. So that's how we're going to interpret that guy. Okay, so percentile of 1862. Okay, and then part 5, we find the percentile now. Okay, the 90th percentile. So find the 90th percentile like that. So what does this percentile actually mean? Okay, so percentile, you first have to find the position of that particular percentile, and then after you find the percentile, I mean the position, okay, you just go to your ordered data and get the number that is there. Okay, so now position of percentiles, it's simply the kth percentile that you have divided by 100 multiplied by the sample size, like this. This gives me the position. Okay, this gives me the position here. So now in this case, I'm finding 90th percentile. So my K is 90. Okay, 90th percentile. So it will be 90 over 100 multiplied by 25. This will be the position. So that could give me 22.5. Okay, so since this guy is not an integer, we move to the next higher integer, which will just be what? 23. So at the 23rd, here, number 23rd is here. So 23rd. So the position is 23rd. Okay, so you just come to this data, count, okay, until you reach 23. That will be the 90th percentile. So this was the 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that will be 22. Okay, so the 90th percentile is 22. Okay, the 90th percentile is 22. Okay, so now what am I remaining with? I need to find part 5. So part 5, it says assume the observations are normally distributed. Okay, construct a 98% confidence interval for the standard deviation of age of students. Okay, so meaning that there we first have to calculate the standard deviation, right? Okay, so let's try to do exactly that. So standard deviation, okay, first have to calculate the variance, and this is for the sample. So the formula is 1 over n minus 1, and then I have summation of all the xi squared minus summation of xi squared over n. Okay, like this. So in short, to calculate this sample variance, we need to find the summation of the x bar. So summation, I mean of the xi's first, and then summation of the xi squared. So summation of the xi's, we already found it when we are doing the construction of the plot box, the summation of 420. Okay, what is remaining is just the summation of the xi squared. So meaning you square this plus square that, just like that. Okay, so let's do that. Okay, so I have 10 squared plus, okay, 12 squared 3 times plus, how many 14s do I have there? I have 4 14s. Okay, and then I square the 14. Okay, plus I have 5 16s. They need to be squared. Plus 18s. How many 18s are there? 5 as well. So 5, and then in the brackets I write 18 squared plus 20. There are 4, so that is 4 in the brackets 20 squared plus 22 squared plus 22 squared plus 24 squared. Okay, so I hope my calculator gives me an accurate answer. Please counter check. So that gives me 7360. Okay, and you know that my n is 25, so meaning n minus 1 is 24. So meaning I can find my variance to be 1 over 24. Okay, and this guy here will be what? It will simply be 7360 minus 420 divided by 25. Okay, so let the calculator do that job. So I have 1 over 24, okay, multiplied by 7360 minus, what is the, okay, let me do this. What is the 420 divided by 25? Okay, that is 16.8. So I'll say 7360 minus 16.8, then multiplied by 1 over 24. So that gives me what now? Oh, I forgot to square this. Okay, so I'm surprised I'm getting a very big number. Forgot to square this. This should be squared. Okay. Okay, so meaning that, let me redo this. Okay, so I have 1 over 24, then multiplied by 730 minus 420 squared, okay, divided by 25. So that gives me 7056. Okay, so this will lead me to having, okay, um, 12.66667. Okay, but let me solve it once more. So 7360 minus 420 squared divided by 25 gives me 7056, and then I divide this by 24. Okay, so the answer is correct. So I found my standard deviation to be this guy. My variance, sorry, h squared to be 12.6. I can just say 67. Okay, that is my uh, variance. Okay, so meaning that I can now use this variance, okay, to find um, a confidence interval. So remember, this confidence interval is at 98% confidence level. Okay, so meaning that my significant level is simply 1 minus c. This 98 divided by 100, that will be 0.98, and this will just be 0.02. So my alpha level of significance is 0.02. So now the formula, okay, for the confidence interval of the population variance, okay, it is given as the following, and we are going to use it to estimate the confidence interval for the what? For the sample variance, standard deviation. So it says 1 minus 1 s squared divided by the chi-square, okay, at alpha over 2 n minus 1, okay, and then I have sigma squared, and then on the other side I have this same thing on top, but down there it will be the chi-squared, okay, of now 1 minus alpha over 2 comma n minus 1. Okay, so these guys, we find them from the table, from the chi-squared table. But what is the n minus 1? Then sigma squared. So that will just be 24. Sigma squared is 12.67, like that. So when I multiply that, okay, so 12.6 multiplied by 24, that would be 304.000, and then I can say an 8 at the end. Okay, so there are a lot of zeros here, and then there's an 8 at the end. So I'll just say 0, 0, and then 8. Okay, so that is what the number on top means. So now, in this chi-squared, you can see I have alpha over 2. So this is 0.02 divided by 2, that will be 0.01. And then on the other side, I have 1 minus alpha over 2, which will just be what? 1 minus This alpha over 2 is this 0.01. So this is going to give me 0.99. So the chi-squared values that I want to get from the table are chi-square value 0.01, 24, and chi-square value 0.99, 24. So I have to get this from the table. Okay, so let's go to the table and then get this guy. Okay, so this is the chi distribution table. So remember, I'm looking for chi squared at 0.01 and then comma 24 and chi squared at 0.99 and then comma 24. Okay, so where is the 0.99? It is here. Okay, and the 0.01, it is there. So I just have to move now down where the 24 is. Okay, so let me erase this. So where is the 24? Let's just follow where those things are pointing. So the 24 is there. Okay, so you can see the first value that we get, okay, at 0.99, and then this is 24 here, you get this guy, 10.856. Okay, so let me write it here. 10.8, sorry, 856, and then the other one, it's what? Okay, the other one gives me this. Okay, this is the 42.980. 42.980. Okay, so once I have those, I can find my uh, confidence interval. So whatever is on top there, it's 30. Okay, I'll just say 0. If I round it off, divided by this guy here, okay, is this guy. So that is 42.980, and then sigma squared. This guy here is still 304.00 divided by this guy is at 10.856. Okay, so we can divide those now to find our confidence interval, first of all for the variance, and then we'll square root to find the confidence interval for the what? For the standard deviation. Okay, so just punch this onto the calculator and punch this onto the calculator, and then see what you are going to get. Okay, so let me do that. So I have 304 divided by 42.980. So that gives me 7.0730572236 less than sigma squared less than 304 divided by 10.856. That gives me 28.000295. 4768. Okay, but this is for variance, sigma squared. I need to find the one for the standard deviation. Okay, so I take the square root there, take the square root, take the square root. So the confidence interval for the standard deviation, which will just say sigma, is what is the square root of this guy? What is the square root of the odd? So this is 5.291 781144. And then on the other side, square root of 7.0730572236. So that will be 2.6595219. Okay, so that will be the confidence interval. So confidence interval 2.56595, comma, on the other side 5.291.7. Okay, so that should be rounded off to 8. So this here is the confidence interval at 98% confidence, okay, for the age of the students for the what? For the standard deviation. All right, so thank you so much for watching. This has been Tutor Pro Solutions. Until next time, always there for you. And if you need more videos, of course, we have more videos on our website, which is discretelearning.com. So make sure you visit the website, subscribe for the course, and it will be easier for you to actually pass your assessment.